All right, welcome to this explainer where we're going to dive deep into Cisco's application-centric infrastructure, or ACI. We're going to tackle one of its most powerful and, let's be honest, sometimes confusing features, using contracts for route leaking between different network segments. Okay, so here's what we've got on tap. We'll kick things off with the dual role of ACI contracts, then get into the provider-consumer model. We'll talk scope and visibility, and then the main event, leaking routes between VRFs and even across tenants. And don't worry, we'll finish up with a hands-on configuration and verification checklist. All right, Section 1, ACI contracts and their dual role. So first things first, let's really get to the heart of it. What exactly is the job of a contract in ACI? Because, getting this right is the key to everything else we're going to talk about. So the first thing you have to burn into your brain about ACI is that it operates on what's called an allow list security model. What does that mean? It means by default, nothing can talk to anything. It's completely locked down. Your endpoint groups, or EPGs, are totally isolated right out of the box, no exceptions. So how do you open things up? Well, that's where the contract comes in. This is that explicit policy we were just talking about. The easiest way to think about it, it's basically ACI's version of an access control list, an ACL, or a simple firewall rule. It's the thing that defines the rules for who gets to talk to whom. But here's where it gets really interesting, and this is probably the most critical takeaway of this whole section. A contract in ACI isn't just doing one job, it's doing two. First, it allows traffic. It's your security policy. But second, and this is huge, it's also the tool we use to enable route leaking. It's what lets us build the paths between different VRFs. It's like a security guard that's also a traffic cop. Okay, Section 2, the provider-consumer model. So we've established that a contract is a set of rules, but rules need direction, right? How does the ACI fabric know which way the traffic is supposed to flow? Well, that's where the provider-consumer model comes into play. It's all about adding intent to our policies. To really get our heads around this, let's look at a super common setup, a classic 3-tier app. You know the drill. You've got your clients, a web tier, an app tier, and a database tier. Now, in ACI, each of these would be in its own EPG. So the big question is, how do we connect all these pieces securely? This is the perfect example to break down that provider-consumer relationship. Let's start with the provider. It's pretty self-explanatory, right? This is the EPG that is providing a service. It's the server. So think of your web server EPG that's serving up HTTPS traffic, or your database EPG that's providing, a database service. And then you've got the consumer. This is the other side of the coin. The consumer is the EPG that's reaching out to use or consume that service. So going back to our example, the client EPG that's browsing the website, that's your consumer. Okay, let's put it all together with this diagram. See the arrow? It goes from the client EPG, which is our consumer C, to the web EPG, our provider P. That's the direction the policy gets enforced. But check out the really cool part here. Look at the management EPG. It's consuming a single SSH and ICMP contract that's being provided by all three of the application tiers. That's efficiency. It's a fantastic example of a key design pattern in ACI, reusability. All right, Section 3 is all about controlling scope and visibility. So, great, we can make rules and we can point them in the right direction. But the next logical question is, how far do those rules actually apply? How far can they see? This is where we get into the nuts and bolts of scope. I mean, think about it. When you're building out any kind of complex network, you're always asking yourself this. What's the blast radius of this policy I'm creating? Can this EPG in one VRF see an EPG in another? Can a contract I built over in tenant A be used by someone in tenant B? The answer to all of these really important design questions comes down to one thing: scope. This table here really lays it all out. You can see we've got different knobs to turn for scope. For a contract, it can be super narrow, like just within an application profile, or really broad, like tenant-wide or even global. But for what we're trying to do here, leak routes, I want you to zero in on two things. Number one, under the bridge domain, that subnet scope has to be set to shared between VRFs. That is non-negotiable. And number two, the contract scope usually needs to be bigger, like tenant or global, so that both EPGs in their different VRFs can actually see it. And here it is, right in the APIC. It looks so simple, doesn't it? Just one little checkbox. But this shared between VRFs option under your bridge domain's subnet configuration is everything. If you want to leak routes for a particular subnet, you absolutely positively have to check this box. It's the magic button. All right, let's move on to Section 4, route leaking between VRFs. Now that we've got all the building blocks in place, the contracts, the provider-consumer model, the scope, we're ready to put it all into action. Let's tackle our first big challenge, getting EPGs in different VRFs to talk to each other. So, here's the challenge. By design, a VRF is basically its own little universe. It's like having a completely separate router with its own private routing table. EPGs in different VRFs, they might as well be on different planets. So, to bridge that gap, we have to do what's called route leaking. We need to carefully copy specific routes from one VRF's routing table into the other. And what's the tool that lets us do this? You guessed it, it's the contract. Okay, let's level up. Section 5, communicating across tenants. This is where things can get really tricky, but also really powerful. We're talking about secure communication between EPGs that live in completely separate, isolated tenants. So here's the problem in a nutshell. The walls between tenants are even thicker than the walls between VRFs. By default, a contract that you create in, say, tenant A is completely invisible to anyone in tenant B. So how in the world do you connect them? Well, the most elegant answer is something called the common tenant. ACI gives you this special tenant right out of the box, and it's designed for exactly this situation. Think of it as a neutral shared space. When you create a contract in the common tenant, it magically becomes visible and available to every other tenant in the fabric. This is an absolute game changer for shared services. You define your DNS or DHCP contract once in common, and everyone can use it. And here's what that actually looks like when you're configuring things. So let's say you're working inside tenant T15 and you go to add a consumed contract to your EPG. In that little drop-down menu, you're not just going to see the contracts you build inside T15, you'll also see those shared contracts from Common, like the ones for DHCP and DNS. Super simple, super effective. Okay, enough theory. Let's get our hands dirty. Section 6 is our configuration and verification checklist. We're going to walk through the exact step-by-step process to get inter-VRF route leaking up and running, and then, just as importantly, how to prove that it's working. Here's our 5-step plan. Pretty straightforward. First, we associate our bridge domains to our VRFs. Then we configure that critical subnet scope. We'll associate the EPGs, define the contract relationship, and finally, we'll verify our work. Step 1, get your foundations right. You have to make sure each bridge domain is tied to the correct VRF. So as you can see right here, we're making sure our DB bridge domain is in the DB-VRF and the web bridge domain is in the web VRF. Simple, but you got to get it right. Okay, step 2. And I'm going to say this again because it is the most critical step. For any subnet you want to be part of this route leaking magic, you have to find this checkbox and you have to check it. Set the scope to shared between VRFs. If you forget this one little step, trust me, nothing is going to work. Now, after you've pushed the config from the APIC, it's time to jump onto a leaf switch and verify. And your best friend for this is the command show VRF detail extended. What we're looking for is confirmation that our VRFs, the DB VRF and the web VRF, actually exist on the switch. And you can even see that each one has been assigned its own unique VNID or VXLAN network identifier. That's how ACI keeps the traffic for each VRF totally separate on the back end. And this is the moment of truth, the final proof, a simple ping. We're pinging from a web host in one VRF to a database host in a completely different subnet, in a completely different VRF. And look at that, it works. This one successful ping proves everything we've done. It shows the contract not only allowed the ICMP traffic, but more importantly, it orchestrated all the underlying route leaking to make the path possible in the first place. So there you have it. We've seen that ACI contracts are so much more than just a simple firewall rule. They're actually a powerful routing tool. And once you master this, it just opens up a whole new world of possibilities for building really secure, multi-tenant networks and elegant shared service designs. So the real question I'll leave you with is, now that you know how to do this, what cool things are you going to build? Thanks for joining this Explain.